So in this video, we're going to continue topic 7.7, which is solving radical equations. And we're going to look at C, the Explore. We're going to graph both sides of the square root of x minus 4 and then x plus 1. So I've already got the 4x minus 4 in there. I'm going to do y equals x plus 1. And you'll notice that they have no solution, so 0. Okay. Now I'm going to do the 1/2 and 1/2 x instead of this, so 1/2 x. And you'll notice that it has one solution there, and look up here, it has a second solution. So there are two solutions this time. And then on the last one here, we're supposed to put in 2x minus 5. And on this one, there is one solution. So you'll notice that there's probably not going to ever be any more than that. When we have this, and they did not give us a reflect question on this. So when we have a radical equal to a line, there will be 0, 1, or 2 solutions. Okay. All right, let's look at D. So D says we're supposed to graph both sides. It's equal to a radical. So let me type in these new ones here. I'm just going to X out what I've got. And then I'm going to go y equals square root of 2x minus 3. And y equals square root of x. That's not what I wanted to type. And notice I have a square root equal to a square root. Notice they only intersect in one place. They're never going to intersect anywhere else when I do this. So it's got one intersection point right there. All right, let's try it with another square root and see what happens. So we have the same one there. We're going to put in y equals square root of 2x plus 3. Ooh, look at these guys. They never cross. Check that out. So never cross. So there's no solutions on that one. Ooh, not that. 0 solutions. All right, so in D, so I'm going to look at number 4 here, and then I'm going to go back to 3 there. The graphs of the second part of step D appear to get closer and closer as x increases. How can you be sure they never meet? That is, that they never really have no solutions. And what we could do is we could actually solve this. So if I squared both sides, we'd get 2x minus 3 equals 2x plus 3. And then when I subtract the 2x to the other side, I get 0. And then when I add the 3 to the other side, I get 6. And because I got something that was false, okay, I got a false statement, that's something that means that there is no solutions. Okay. I don't know what happened because mine says C and D, and I have no clue what happened. But this is not the question that answers C, so this is kind of its own thing. We'll call it E for now. So what they wanted us to do is graph the cubed root and set it equal to a negative and a positive. So let's try that really quick. So to get a cubed root in here, we get y equals, and I got to go to my keyboard. I'm going to go to functions and the nth root. So I'm going to use a cubed root, and I'm going to type in, let's see, what did I make up there? I made up 2x minus 1. So 2x minus 1. And you'll notice that the cubed root looks a little bit different. It looks like a cubic function kind of laying on its side. And let's set it equal to, positive 1. You'll notice it crosses one time. So we've got one solution there. All right, and let's look at what happens when it crosses, when we just make it a negative 1. It still crosses once, and I mean, it's going to be slow. No matter what I did, I could put a negative 4 in, and eventually I'm going to get it to cross somewhere. It's just going to be very slow. So it looks like it has a solution. So this one also has one solution. So it looks like it's always going to have a solution. Will the number of solutions depend on the sign? And that would be no. There will always be a solution. So basically what we proved is that a cubed root can equal a negative number. solution.